Welcome! In this lesson, we will learn the essential trigonometric identities, what they mean, and how to use them with clear visuals. We will cover reciprocal identities, quotient identities, Pythagorean identities, even and odd identities, cofunction identities, sum and difference formulas, double angle and half angle formulas, product to sum and sum to product identities, and periodicity. First, big picture intuition. On the unit circle, the x-coordinate is cosine of theta, and the y-coordinate is sine of theta. If we drop perpendiculars to the axes, we can see sine and cosine as horizontal and vertical projections. Now, reciprocal and quotient identities. Reciprocal identities say secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. Quotient identities say tangent is sine over cosine, and cotangent is cosine over sine. Remember the domains. You cannot divide by 0, so avoid angles where the denominator is 0. Pythagorean identities come from the unit circle. Since cosine squared plus sine squared equals 1 on the unit circle, we have the identity. Sine squared plus cosine squared equals 1. Dividing both sides by cosine squared gives 1 plus tangent squared equals secant squared. Dividing both sides by sine squared gives 1 plus cotangent squared equals cosecant squared. Even and odd identities. Sine is odd, so sine of negative x equals negative sine of x. Cosine is even, so cosine of negative x equals cosine of x. Tangent is odd. Secant is even. Cosecant and cotangent are odd. We can see this on the graphs. Odd functions are symmetric about the origin. Even functions are symmetric about the y-axis. Cofunction identities use complementary angles. Sine of 90 degrees minus x equals cosine of x, and cosine of 90 degrees minus x equals sine of x. Similarly, tangent of 90 degrees minus x equals cotangent of x, and secant of 90 degrees minus x equals cosecant of x. Sum and difference formulas. Sine of a plus b equals sine a cosine, b plus cosine a sine b. Sine of a minus b equals sine a cosine, b minus cosine a sine b. Cosine of a plus b equals cosine a cosine, b minus sine a sine b. Cosine of a minus b equals cosine a cosine, b plus sine a sine b. Tangent of a plus b equals tangent a plus tangent b over 1 minus tangent a tangent b. Tangent of a minus b equals tangent a minus tangent b over 1 plus tangent a tangent b. Double angle and half angle formulas. For double angles, sine of 2x equals 2 sine x cosine x. Cosine of 2x equals cosine squared x minus sine squared x, which also equals 1 minus 2 sine squared x, and equals 2 cosine squared x minus 1. Tangent of 2x equals 2 tangent x over 1 minus tangent squared x. For half angles, we can use squared forms to avoid sign issues. Sine squared of x over 2 equals 1 minus cosine x over 2. Cosine squared of x over 2 equals 1 plus cosine x over 2. And tangent of x over 2 equals sine x over 1 plus cosine x, and also equals 1 minus cosine x over sine x, when defined. Product to sum and sum to product identities help when multiplying or adding sines and cosines with different angles. Product to sum. Sine a sine b equals 1/2 times cosine of a minus b minus cosine of a plus b. Cosine a cosine b equals 1/2 times cosine of a minus b plus cosine of a plus b. Sine a cosine b equals 1/2 times sine of a plus b plus sine of a minus b. Sum to product. Sine a plus sine b equals 2 sine of a plus b over 2 times cosine of a minus b over 2. Sine a minus sine b equals 2 cosine of a plus b over 2 times sine of a minus b over 2. Cosine a plus cosine b equals 2 cosine of a plus b over 2 times cosine of a minus b over 2. Cosine a minus cosine b equals negative 2 sine of a plus b over 2 times sine of a minus b over 2. Periodicity identities. Sine and cosine repeat every 2 pi. Tangent repeats every pi. That means sine of x plus 2 pi equals sine of x, cosine of x plus 2 pi equals cosine of x, and tangent of x plus pi equals tangent of x. Quick example 1. Rewrite sine x plus cosine x as a single sine. We can use the angle addition formula to show that sine x plus cosine x equals square root of 2 times sine of x plus pi over 4. Quick example 2. If sine x equals 3 over 5, and x is in quadrant 1, find sine of 2x. We first find cosine x equals 4 over 5 from the Pythagorean identity. Then sine of 2x equals 2 sine, x cosine, x equals 24 over 25. To summarize, trigonometric identities are powerful tools. Keep a mental map of the families: reciprocal and quotient, Pythagorean, even and odd, cofunction, sum and difference, double and half angle, product to sum and sum to product, and periodicity. Use the unit circle, graphs, and right triangle intuition to remember and apply them with confidence.